Ever look at the airplanes soaring proudly through the sky and wonder how does the massive thing stay up there? It seems like magic, but it is actually a beautiful dance of physics. Today, we are going to unravel the mystery and explain the four fundamental forces that allow an aeroplane to fly. Think of it like a constant tug of war. For airplanes to fly and move forward, these four keys player need to be an avalanche. Let's meet them one by one. First up, we have the leap. This is the superhero force that directly opposes the gravity and keep the plane from falling out of the sky. It's primarily the jobs of the wings to generate this upward pushes. Take a close look at the shape of the wings. It's called an airfoil. Notice how it is curved on the top and generally flatter on the bottom. This specific shape is secret behind generally generating lift. As the plane moves forward, the wings flies through the air. Now here's the clever part. The curved upper surface forces the air travel over the curve a long distance compared to the air following underneath. To meet up again at the back of the wings, the air on the top has to travel faster. This is where the Bernoulli principle comes into the place. This principle states that the faster moving air exerts lower pressure, so the air pressure on the top of the wings becomes lower than the pressure on the bottom. Imagine it's like a higher pressure underneath. The wing is literally pushing it upward toward the area of the lower pressure above. This pressure difference creates a upward force we called damping. Another crucial factor is generating lift as the angle of attack. This is the angle at which the wings meet the oncoming air. A slight upward will help to deflect the air downward, which as well as see which are our next forces also contribute to lift. However, there is a limit. Too much angle and the airflows become destructive, leading to losses of the lift. Next up, we have the weight or the force of the gravities. This is the natural downward pull on the airplanes due to its mass. The heavier of the planes, the greater of the weight. To get up on the ground and stay in the air, the lift generated by the wings must be greater than or equal to the plane's speed. It's a constant battle against the gravity. Now, how does the plane move forward in the first place? This is the job of the thrust. That is the job of the thrust. This is the power force that propels the planes through the air, allowing the wings to generate lift. Thrust is produced by the plane engines. In the jet engines, air is stocked in the compressed to high pressures mixed with fuels and then ignited. This creates a powerful explosion and the hot gases are expelled out the back at incredible speed. These explosions of the gases create an equal and opposite reaction, pushing the engines and therefore the entire plane forward. This is a perfect example of Newton's third law of motion. For the planes with the propellers, the principle is similar. The spinning propellers blades are shaped like airfoils themselves. As they rotate, they push the air backward and again they create a forward reaction force thrust, pulling the planes through the air. Think of it like a powerful fan pushing the plane forward. Finally, we have drag. This is the force that pulls the plane's motion through the air. It is an essential air resistance trying to slow down the planes. There are the different types of drag. From drag is the resistance caused by the shape of the plane's peak. The streamlined design helps to minimize this. The skin friction drag is the friction between the air and the surface of the plane. A smooth surface reduces the stress of drag. And lastly, induced drag is byproduct of the lift. Remember how the wings deflect air downward, this creates a streamlined air pattern wing. We call them vortex, which casts some drag. For the planes to accelerate and maintain its speed, the thrust generated by the engine must be greater than our total drag acting against it. During takeoff, the engine works hard to generate maximum thrust, propelling the planes to the runway. As the plane gains speed, the airflow over the wings increases rapidly and the lift starts to build. Once the generated lift becomes greater than the plane weight, the plane finally takes off and begins its arcs. During the crescent altitude, the forces balance lift equal weight, keeping the planes at a constant speed and height, and the thrust equal drag maintained at steady speed. When the pilot wanted to turn, they used control surfaces on the wings of the tails. They changed the airflow, creating a temporary imbalance in the forces caused by the plane's roll and general direction. Finally, for the landing, the pilot reduced thrust, which in turn reduced speed and lift to compare for learners. The speed flag on the wings and arms extended. This increased both lift at lower speed and also increased the drag, helping the planes to slow down safely for landing. Think of it to our favorite airplanes when you throw a forward that you trust. The shape of its wings create a little bit of a lift as move through the air. Gravity pull it down and the air resists Earth's moment. A real aeroplane just touch this on the much larger and more controlled scale. So the next time you see a plane in the sky, remember this is not a magic but a beautiful interplay of lift, weight, thrust and drag, constantly balanced and controlled to keep us safely soaring through the air.